and moving forward to the first session of the day by the Thiruvananthapuram chapter, where we are going to talk about Confessions of an Infrastructure Architect by Jiju Thomas. So without any further ado, let me welcome our first speaker for the day for Thiruvananthapuram chapter. Welcome, Jiju.
Good morning. So, I'm presenting on this platform for the first time, and though I have been presenting on multiple platforms through other medias and all that, this is the first time I'm presenting online. There may be some hiccups. Anyway, let us proceed. Actually, this is my bio, where I have a 30 plus years experience. I started developing in 87 onwards. I'm part of the Amazon Web Services user group, AWS user group in Trivandrum. I'm the co-founder. I have worked in different companies, different platforms, publishing, information technology, cloud management, infrastructure authoring, infrastructure architecting. And I've been utilizing mostly open source tools, open source solutions. Um, well, a basket full of them has been implemented in multiple different companies where I had worked. I had given solutions, support, consulted, and even I have during some time I had even worked as a freelancer in multiple freelancer portals also. For this particular session, the key takeaway is I've selected three projects of which has helped me and given me opportunity to train myself on different aspects of migrating to cloud. Well, why I did certain things and what was the outcome and what was the solutions which was used for certain bottlenecks which I felt. All these things we'll be discussing in detail, which we consider with each project. Let us proceed with that. Okay, the selected case studies are at least some of you may be knowing about the virtual queue, the Shabarimala virtual queue, which was a solution which was built for the Kerala police through a contract from the Keltron in Trivandrum, which was a BOT project, and we built it in 2010, and the BOT contract was over in 2016, but they wanted us to run the project once more in 2017-18. Also, we manage the project and run it without any changes, of course. The second one which I have selected is my own WordPress portal, which was a burden to me, like $40 per month when I was running it on AWS itself using a light sail instance. On a particular situation, I thought about moving it to a static site because the number of updates, the update frequency, the change frequency, etc., is very low, and the commenting was, of course, on Discuss. So I thought about a particular system to push it. I have reduced the monthly cost from $40 to $3, less than $3, of course. The third project is something which I have done for a overseas client, but the client which I have rewritten in my portal is a fictitious one. I have put it as a National Highway Authority of India. But National Highway Authority of India will never implement such a project because they don't want that kind of transparency in their construction work and all that. Well, it is a rather transparent construction reporting system where building actually it was built for a builder. So their portals or their plots which was getting revamped and built, they wanted everyday updates like almost close to an update per hour or something like that. So multiple portals were updating to that. We'll come to it in detail. Each project I'll take it in detail. Now let us proceed. I think let us proceed. Talking about Shabrimala virtual queue, we were awarded the project. In fact, the Kerala Police Cyber Cell team and somebody from the police department itself tried building something in 2008 9. In 2008 9, they didn't launch it properly. In 2009 10, they did it, completed it, and they launched it using the state data center with a couple of servers, one database server, and all that. But the potential and the depth of the users, the first second week or the third week into the launching of the portal started crashing because of the huge request that is coming in. And in 2010 they thought about taking some cloud services, and somehow our company, that company was the company which I was working with was Saturn System Works Private Limited in Technopark. Our company was selected and suggested by the Technopark team itself, and finally we got the contract through as a subcontract from Keltron, and we we were building for the cloud on the very first time, and we built a totally new framework itself. It was both 100% PHP based. There was nothing else. I was a PHP guy since 2000 onwards. I started developing in PHP 4 and climbed up all the way to 7, now running with 7.3 and all that. Now I'm not using any development language, but still Node.js and JSON is there. Anyway, this was a PHP framework was made. The framework was later made open source after the BOT was transferred and they dropped the project. The framework was made open source and it's available on my GitHub portal. Anyway, totally new framework just for this particular project, which had some minor tweaks which to utilize the AWS. That is, the assets and static assets and the user data like uploaded photographs, etc., were put on S3. Otherwise, it was totally a traditional data center model. That is the Apache, PHP, and MySQL. Of course, it was we first time we used MySQL, and it was a pretty complicated implementation because we had to implement a MySQL cluster because a single server would not take the load and all that. So we had built a Galera cluster in the first time in 2010. Then also the scaling was horizontal and manual. That is, predicted time we were a couple of us were monitoring the whole thing through the CloudWatch and managing the system manually. When spikes are occurring, we just simply start 2 or 3 or 4 uh, virtual machines and connect it manually to the elastic load balancer and all that. So it was a hectic process in 2010 11. And in 2011, we did some revisions. We switched the scaling from manual to auto scaling using recommended practices from AWS. Even then, auto scaling could be configured only from the command line. There was no interface for auto scaling. The interface for auto scaling came in 2013 June only. And that is when we did our third revision with scaling with multiple instance sizes. Like in the middle of the night, the whole system was running on micro instances. That is, the instances which has 1 GB RAM and single core. And by 6 a.m., we shifted from that to 4 GB RAM and dual core. Even that also the T series only. And by 8 we shifted from that to M4 instances, and 10 onwards we started launching spot instances. So this was a multiple instance sizes and mix and match and all that. These combinations were further discussed on AWS threads, blocks, etc. And now they have built it into their UI itself, such that you can have multiple sizes, multiple combinations into one auto scaling group with some rules and all those things. And in 2014, when we did all this, we had a cost reduction of almost 60% because the base machines of a fleet of 3 were on demand, and after that, whatever we run only spot. That means we could get a drastic reduction in the cost. Fourth revision in 2015, we shifted the image validation, resizing, and of course the coupon or the PDF generation. PDF generation, all these things we shifted to manage microservices using AWS Lambda, which was a new entrant. That is, in 2015, uh, March only, this came out, and the first offering was available through Node.js, Java, and Python only. Later on, they added n number of runtime services with which can have anything. Even now, PHP and all we use on microservices in AWS Lambda. So at that time, Node.js and Python and Java was the only availability. PDF generation, of course, we wrote in Java. So a single project could have multiple programming language, multiple divisions, and even remote developers could be brought in, because the generation of the PDF is just an input of JSON and a PDF output. So that is fully detached. And that was a big advantage for us to do. And of course, we had cost savings. Cost savings means we were running a dedicated 3 dedicated large instances for the PDF generation, and that used to hit a bottleneck at around concurrency of 180, 190 concurrency. That is when 190 requests of PDF generation was hitting on the cluster of 3 large instances. After that, things started queuing, all that. So that the concurrency was around 190 to 200. And when we shifted to AWS Lambda, we reached a concurrency of 480 without queuing. That means at a particular point, I can show you only a 2012 graphs, data graphs, but imagine what it is. Then the next screen is a data graph. I'll show you that. And the concurrency has increased more than 200%. So this could be achieved only using the microservices in AWS Lambda. This was the first time we were using it, and in 2015 itself, we tried deploying these Lambda, and we have, in fact, I myself have helped AWS to resolve almost 35 bugs in the Lambda system by reporting all those bugs, which was one way or other way. We expected something, it was not there, and there was a lot of iterations. They gave us a lot of support. In May, June, July, we were doing all the tests, and finally in August or September, we shifted everything from Singapore to Ireland, because Lambda in production was available only in Ireland. That was the nearest for us, and that got everything got wind up in 2017. 2017-18 was the last season which we run it. 2018 January, we wound up everything and packed it and gave the source code, database, everything to Kerala Police on disk and all that. And that was the end of it. Then after that, they have not asked us to run it. So after that, the PHP framework was made open and it is available on GitHub. Even before it was available, but it was a very minor version. But I have done a lot of upgrades in between. There are pub plugins and all that. So it's available on my GitHub. So the framework is named as PHP MF, and I haven't specified my GitHub account anywhere, but it's Jthoma. It is JTHOMA. Okay. This is a graph which depicts the data which was built using. We just did the graphing using Webalizer, and this is the only one which I could get from an old data. It's a 2012-13. 2012-13. This analysis is done on the cloud front. That is this content delivery network. The content delivery network. So if you look at the columns, you can see there are unique objects of 1,372 and a total. That's the monthly totals, and the total traffic. So there are hits of blasting figure. I don't know how to read that figure out. Anyway, even though there are so many hits, the original pull is only 1,130 edge locations across the 4 months. There was 1,372 unique objects. Some objects are, of course, requested but not found. So origin pull happens only on 1,137. So this was a big blast. The whole thing was delivered from Edge only. So this covers only the JavaScripts, images, CSS, things like that. There may be some differences. That is, the image, the CSS may have been upgraded across months. That is why in October there is 23 unique objects and 23 origin pull. In November, there is 659 and 578. So there is some change, means that change is maybe due to some version changes in the CSS or some banner changes, advertisement changes. These things may affect. But still, the total number of origin pull, that is from S3, the edge was pulling only 1,137. But a very large number of hits was handled by the edge. This saved us a lot in traffic, of course. The traffic charges, of course. AWS so the edge delivery is almost close to one by 10 of that of the origin pull. If you are having an origin pull every day, then your CloudFront does not serve any purpose. That is why I just wanted to show you this. Okay. This I had given a brief at the top, but it's my own portal. Agree. It was originally phptrivandrum.org. Then I shifted it to my own name. It is jujutm.com, and it's just a WordPress to static. I have done this for multiple different companies. The company which I was working before is IVL, and IVLDSP.com is also almost static. It is, even though it's a WordPress, it's a static site hosted on S3. The same way only my jujutm.com is also hosted as a static on S3. They the decision is because the low frequency of changes. That is one or two posts per month. Normally, it happens on a weekend, and I don't want to keep up with the updates, etc. And that is whenever WordPress does an upgrade, I don't want to go immediately into my WordPress portal and make an upgrade. Otherwise, so all these things are the main reasons, and of course, the cost factor is there. That is, if you don't upgrade your WordPress to the latest, your security patching may not be done. Then, when you upgrade, you may need to upgrade all the plugins. When you upgrade the plugins, maybe your theme customizations might break or fail. Then you have to go and do those things. So, every time you do an upgrade, you may need to tweak the theme. You may need to tweak some and by the time you find it out, your SEO ranking may have been dropped. All these things are complications. So I just did not care about it. And the solution was to run WordPress locally using Docker on laptop. I'm not a Windows guy. I'm a Linux guy. I'm even doing the presentation from my Linux laptop. A Docker on laptop. Use some custom scripts utilizing that is wget, grep, sed, awcli, etc. to rebuild the site as a static and push it to S3 and full site delivery through, of course, CloudFront. So this I required to some extent. I needed some rewrites, that is URL rewrites, redirects. There was download counter. All these things were made using microservices in Lambda and Lambda at Edge. All these things are services in the. So these were done. And finally, the outcome is the reduced monthly bill. I was paying around $40. I'll show you two. That is the 2020 January bill and the 2020 December bill. I'll show you because I did it in between. There was a lot of other research in between. So there was other billing. I had even gone $140 in June when I was doing some other research. So the billing was in January. It was $40. I was just running my portal alone, and in December it came down to less than $3. I'll show you the exact figures. And the site is, of course, static. Nobody can hack in unless AWS S3 is compromised. And so somehow, if all of you is going to hit my site, it will be same latency for everybody. It doesn't show any degradation. It will show you the same latency for everybody. So that is the main outcome of this situation. And excuse me, 1 second. So this was my January 2020 bill. You can see the circled value. It is a 40.04. Of course, it's a credits. As you can see, I'm a AWS community builder. So I'm getting this credits from the community builder project program. So I have the credits over there. So even though it's credits, I'm spending from my credits. So I wanted to reduce. It's actually researching and doing reducing cost expenses. That is a major thing in AWS or any other cloud service. So this was my December 2020. You can see that it is a December 2020 bill, and the amount is $2.34. I just rounded it to three. Two for the slide, I told three, but it is 2.34. So that just this is just running my portal only, and yeah, this is a project. We'll come back. I'll just skip to the next slide and then come back. This is the architecture which I have built for. I'll explain the architecture. We'll come back to the architecture when this is the architecture. I just wanted to show you the complexity of the architecture. That's all. Now we'll come back to the situation. Okay. The project was designed on AWS with microservices and distributed architecture connected with events and triggers and API first approach. I was only responsible in architecting the backend. The front end was being developed in multiple uh, platforms. That is, there was a couple of mobile applications, one for the public or actually the clients, and one for their in-house team. Then they had a central administrative portal. These things were being built by different teams. I think and even the mobile applications were to be published on different platforms like Google and Apple. Of course, you have to have a mobile application. I'm not familiar with mobile development. My only responsibility was handling the backend. So I just had a my team. I had a team who built a POC. That is, almost all the UIs were built on a web application using Bootstrap, jQuery, etc., and all that. Because my team was familiar with that only, and we abstracted using the API gateway And once we deployed it, we had some challenges that the API gateway started to be getting really costly because the number of requests. API gateways, number of requests, and the data transfer, caching, all these things are chargeable. So we shifted from API gateway to network application load balancer. Sorry, application load balancer. That is ALB. That's a newer feature. And ALB is something like data transfer and minimum charges. So we saved something over there by changing this architecture from API gateway to application load balancing after the initial deployment of the project. Anyway, this is unlimited scaling. Lambda is used. DynamoDB is there, and Elasticsearch as a service. Then mostly the media files, the photographs are stored on S3. The user authentication is through Cognito, and inter-process communication through SQS, buffering, all this is in SQS, and SNS for the notifications, etc. When nobody is using, you're not paying anything, and somebody is using, you're paying, and many people are immediately using it, you're ready for the hit. That is the advantage with which when you're building using the uh, microservices on AWS in a fully distributed architecture. There was some plugins because we are very in fact I am very much well versed in WordPress. I'm part of the WordPress community also here, and I'm very much part of the WordPress. Started using WordPress in 2004. So since I'm very much into WordPress, I built a plugin for WordPress for the whole thing using the API abstraction. And of course, I have been heavily using CodeIgniter. So I instructed my team to build a CodeIgniter plugin also. That's not a plugin, it's a helper. So that the individual project portals could abstract the data from the project. Actually, this is something like what do you say, a developer who develops a property by building a flat or or a big construction. So they are reporting with every hour. They are taking some photographs, uploading. The photographs are taken using the mobile application in the mobile itself, so that it gets updated with the geo data, the time, and the allocated project. No, actually, the geodata and the project is interlinked. So a click of photograph would be enough to capture this data, and these are uploaded in sequence to S3 bucket, where an upload will trigger an event. Then the photographs are resized with multiple thumbnail size that is automatically happening in the background. Then the metadata will be extracted. All these metadata will be buffered into SQS and written into DynamoDB, where triggers will generate, and again different lambda will be running to write it into Elasticsearch service so that it can be indexed, searched, etc. So these happenings are all in in AWS managed microservices. Now let us go into the architecture. There are two architecture, of course. One particular architecture which was following the AWS recommended practices by multiple service providers and all that. It was to use the elemental media connect. You can see at the bottom there is a elemental media connect. That is the first one. Sorry, the first one slide is having the AWS elemental media connect to uh, do the transcoding. That is when one project is over. When the project is over, what we do is we take all the major changes. Each pictures are compared together to find out the major changes. Then the major changes are stitched together to build a video. And that process was being handled by Elemental Media Connect. Now, the transcoding will also happen there. That means multiple devices require multiple resolutions. So all these resolutions were also being built over there. Initially, we deployed it. We just did some bare minimum testing with some simulated values by adjusting some timestamp, geo coordinates, etc. And when we analyzed the billing pattern, we found that the media connect is going to be like hell. The cost is going very high. That was not the one which we agreed for the runtime costing. That is why we shifted the architecture to the second one, that on the right hand side. On the right hand side, exactly the media connect and step functions was replaced with a lambda and an EC2. And the EC2 was spot instance. The costing from the initial, if we went with the production, if he had gone with the production, the costing could be almost 7 to 8 times that now is really running. The product is running in an OSIS for an OSIS client and is running at a cost which much lesser than the client expected. So that is how my kind of architecture. Because uh, I think I have almost reached my end of the presentation. This Can we take some questions now? So for the questions, should I stop sharing or? Oh, I don't know what to
Hi, Jiju.
Yes, yes, yes.
Thank you for a wonderful session.
Yes. I'm seeing some questions even. I
Yeah,
never
yeah. So
worried
I
about
will
this.
read out these questions to you. We have a couple of questions from the audiences, and we would love to hear from you. So
Yes.
there's one question. Yeah. Okay. There's one question, Jiju. How to enhance the cloud experience with Agile collaboration for projects?
To be frank, I'm not that expert with the. Yeah, I don't even know what is it. Well, mostly I was into single phase of the development. Like I was just architect only. So how I do the architecture is I use command line tools like serverless application model, AWS SAM, and cloud development kit (CDK). The advantage is that this maintains the architecture as JSON documents. So we can have step by step. That is the whole architecture we can build. Think of multiple components, then we can build these multiple components, test each component, combine it together, and build the whole thing together in one go. So that is Not like yeah, of course, we build one component, deploy it, build another component, deploy it, then connect this. If we go back into my slide, of course, I'll just have a explanation of that. If we go back to the slide, I think you can see the slide. In this slide, what we did was we just deploy the main part, that is the authentication initially. So it was only the CloudFront and Cognito. That was the first thing we deployed. And we collected all the user data immediately into Amazon Cognito. They were asked to sign up. So that we got the user data into Cognito. While users were getting registered and all that, we started deployed the Lambda part. That is the initial APIs. Then, along with that, of course, the upload server. So this was split into multiple units. These multiple units were first deployed, tested individually, then combined together and was deployed as a whole. This was done using AWS SAM, not CDK. CDK came out later only. CDK was much more matured and announced in the reInvent, which happened in November, December. So I don't know about Agile collaboration, but Agile tools have been might have been used, of course.
Okay, thank you, Juju. We have a very long question now coming forward by
Yeah,
Amrita.
I've read I've read through that. Even for that also, I just, the
Let me
please
just read it for our participants also, Jiju, quickly.
yeah.
So, what Amrita is asking is if you can explain for each project team structure, who are the
Mhm.
product owners and other roles, how backlog has managed, prioritized, how milestones and sprints are had designed, how and at which iteration sprint or review demo has been conducted. So there are many questions. Can we go
Yes.
one by one to each? Yeah.
Yeah. No. No.
So
No
let's.
problem.
So
No
she
problem.
asked how he had made sure the continuous learning and improvement were carried out, and any specific agile methodology or framework used, for example, Scrum, Lean, XP, Safe, or less.
Nothing. All these projects, of course, I don't think these are so heavy that we should use some methodology like that, because uh, I never coordinated with any of these people who would build the front end. The front end might have been using some technology like that. I am just bothered. I'm just simply bothered about the backend only, which is using the microservices, and this was written. Of course, I write my code, then run my command line. It just get built, and if it fails, I again do it. So, and the testing, integrated testing, because without having a UI, nobody can test it. As long as I'm pretty confident about what I'm doing, I just simply do it. Well, if you can see, I have my T-shirt. I never touch my code, and even if I do it, I do it on production. That is my mentality. Maybe because I take the responsibility, I take the risk, but that is not the way it should be in a real time in MNCs and all that. That that is why you are asking all these things. I'm not pretty used to all these things, so might be, but I'm not used to it. So it should be required, but I'm not using it. Any nothing like that, because I just write the script for the architecture and deploy it. For the first project, that is Shabarimala project, of course, the whole thing was one man show. There was nothing else. There was only one additional resource that who did the HTML integration. The rest, everything was myself. Developed the framework, I developed the code, I designed the database, connected everything. Everything was connected together. It was deployed for test by the public only. There was a lot of issues in the first year itself, but we managed everything between ourselves within the first 2 3 days, and the production was running smoothly. Of course, this is not the case when we think about major projects now. So we have to implement some frameworks, all these things.
Yeah.
That's it.
Yeah, thank you, Jiju. So moving forward to the next question by Atul. He's asking what is the advantage of distributed architecture regarding
Advantage
cost saving, delivering value to customer quickly.
distributed architecture. The distributed architecture makes sure that your point of failures are distributed. That is, if you just have a single monolithic architecture, anything that fails inside will affect the whole system. A distributed architecture, you have intermittent buffers, and the buffers will take buffering. You have to build the resiliency. That is, the application's resiliency can be built easily. That is, you have a queue processing. If you consider e-commerce purchase, the order processing system places a queue into a queue system. The order, that is order making system, will place a queue into the queue system. The order processing system will pick the queue and start processing the queue. Once it is processed, it will delete or mark it as processed in the queue. So this pro- placement and processing is distributed, and in between you have a buffer. So the distributed architecture will give you that kind of flexibility. If you go back to my slide, you can see that the distributed architecture is in, being implemented using intermittent queues. That is, the queue will buffer and write it to Amazon DynamoDB. So this way, what happens is that all the users who are pushing in may not be directly writing into DynamoDB, but there will be a queue in between which controls the DynamoDB read write request allocation, which saves the cost, of course.
No,
Yeah,
didn't get your point, Jiju, regarding the cost saving of writing. That can you just elaborate more on this with respect to cost saving?
Okay. Okay. By default, AWS managed service DynamoDB is cost is analyzed according to read write allocations. You have multiple options. You can have dynamic read write, you can have scaling, you can have fixed read write. So there are read write allocations. This is called sharding. They are allocating different servers. If you have 5 write units and 10 read units allocated, then it is almost equivalent to allocating 5 different servers for each shard. So if you are allocating 10 write units, then it is almost equivalent to allocating 10 different servers in the backend to write the data. So the read write sharding is very important when you want to write from a direct stream or a buffer. When you are writing from a buffer, you can control the speed into which it is written. But when you are writing from a stream, the stream occurs, each and every user, multiple mobiles will be writing into the same stream, and the stream is getting written into the DynamoDB. So when there is some work, that is, the work may occur only during 24 hours. The building work or the construction work may be occurring only for some period. In that particular, actually it's for Middle East, and in Middle East there is a gap during the peak day hot day hours. So that gap will be utilized, and the writes per second will be distributed. Instead of uh, doing the whole writes per second, that is whole writes in during the work time itself, it is spread out. So that is how we reduce the cost.
okay. Thank you, Jiju. I request you all to post your questions in the chat and we will take them up accordingly. The next question again by Atul Jiju is how to link different distributed architectures to work towards common business goal.
There are building blocks. Mainly, Inter-process communication blocks, which is provided by the AWS itself, is one of it is the SNS, that is a simple network, that is a simple notification system, and the other one is SQS, is a simple queue service. The queue service has got two types. It is a random, and the second one is a FIFO. FIFO is a first in, first out, and random is it may be random. That is two things which are coming in at the same time may be ordered differently. So using this, you can link together multiple distributed systems. Now, for an example, if you consider a airline ticketing system, your airline ticketing system, main core servers and all that may be residing in India itself. But your API service provider is there in the US. And while booking, for starting a booking process, you may have to communicate with the API service, that is a Galileo or a GDS system. During the booking process, you may have to communicate around 40 to 50 times back and forth by checking several things, several aspects, and checking back into your database. All these things happen. Now, if you think about directly interfacing through the open internet, then your latency will be very high. Suppose if you are packing everything, that's packing every request and putting it into a queue, and there is a processor at the other end which processes the queue and does the booking and returns the data into another queue, and another processor which picks up it from the queue as soon as it arrives in the queue and processes it back. So this is a particular example of a distributed system. Like this, any particular scenario, this I explained it because I have done it in a real-time situation. The same way, you can have multiple distributed systems interconnected with SNS or SQS. SNS is one thing and SQS is another. SNS is a notification service where you can have multiple clients attached. That is, a particular notification is sent to a service, and the service is one to many. At the other end, you can have a subscriber like email, you can have a subscriber like HTTP, you can have a subscriber like Lambda, of course. Then there are other services like Kinetic and all that. All these things can have.
All right, Jiju. So there are a couple more questions. We have 6 minutes in hands, and we'll try to answer 2-3 questions more. There's a question by Ranjit. He's asking how well elaborated were the requirements and were there changes between initial architecture and final delivery? Asking since the customer is a government or an organization.
I'll have to get an explanation from Ranjit whether he is referring to the first project or the last project. The last project
Yes.
is just a fictitious name. It's not a government organization. It was for a Middle East customer. It was a private company. Of course, there was no changes after the final first requirement. But for the first project, there was a lot of changes because it was depending on the end users, not because it was a government organization. Their requirement was exactly to the point. They wanted only one thing, and that was initially step by step identified. It was clearly stated. But later on, multiple users, when devotees started going to Shabarimala, they started using it. They had some suggestions. These suggestions were later on incorporated in multiple years to come. When we built it, it was just one go. We built it. We built the UI, got an approval. Then we started integrating into our system. It was an integrated one. But for the last project, actually, it was cut and right. There was initial requirement. The requirement came through. We built it. We made the changes from our end because we wanted to have a reduced runtime costing. That is why we made the changes. We removed the elemental media encoding system and implemented a custom built, what AWS calls as a golden AMI. It's a custom built EC2 instance which was running on Spot. The thing is that whenever a trigger comes in, it starts a Spot instance. It's just the transcoding and just destroys itself. transcoded files will be copied to S3 and then it destroys itself. The particular EC2 instance was running only a command line version of a tool called FFmpeg. So that was a change which I built in after running it in production for a month. It was not a requirement change.
All right. Moving on to our next question. We have 3 more minutes and many more questions, but let's take a question by Ramesh, who's asking, what are the external interfaces where you face challenges in terms of writing interfaces and integration?
Sorry, Ramesh, I have never written any interfaces. I'm just an API guy who does the architecture. Initial project, of course, there were a lot of interfaces, but interfaces was just a headache of my HTML integrator designer. I never did any digging into that. Once the interfaces were finalized and approved, we started building the database and all that.
Thank you, Jiju. We have 2 minutes, and I think we can take up next question by Noor. She's asking which out of the two, read or write replica, implementation, or table partition, is good for huge transitions?
Transitions or transactions, I'm not sure. If it is a transaction,
Noor, could you just write in the chat if you're talking about transition or transactions? Okay.
Well, I'll just go one. I've been working only on NoSQL. Previously, of course, I worked in MySQL, then shifted to MariaDB, and for the past 7 years, I'm away from any SQL structures. I'm using only NoSQL, and NoSQL by default has partitioning. That is why we are declaring about read-write allocations. Okay, let us proceed with the next one.
Make use of the last minute we have, and we would quickly want to understand, Jiju, which common factors to consider while choosing architecture at the start of the project.
Well, that is $1 million question. The thing is that you will have to think about how deep the project, that is a number of users or the customer growth. Of course, everybody want to have that million feet, but is it practical? Will a project grow that much? We have done several projects. Like we have implemented a project for Kodak Bank where the bank officials are the only users, about 600 users. It is running on a small instance. The same time, we had implemented another one for them itself where their field staff and customers are using it. The difference is that they have around 30 lakhs altogether, customers, end users, distributors. All these things are counts to around 30 lakhs of people. We cannot run it on a server, so you have to design it as an architecture. That is how we decide whether we need an architecture or another, that is a distributed architecture or something like that. That's it.
Thank you, Jiju. Thank you for answering all the questions so patiently. I'm sure our participants enjoyed the session thoroughly and have lots of key takeaways to take them back with them after this event. Thank you, everybody, for joining us at Thiruvananthapuram chapter's event. And we really enjoyed having you and Jiju in this event. We will be shortly beginning with our next event by Noida chapter about the power of Agile project management with Agile. So stay back with us. We will be shortly beginning in 10 minutes with our next chapter event. Thank you, everybody.
Thank you, everybody. Thank you. Bye.
Bye.